LLMs hallucinate, and often we want to put the blame on them, but on occasion, or even often, it's also our own fault. Many knowledge bases we use for retrieval have temporal inconsistencies, so they might have multiple versions of the same document from different time periods. They might also have historical information without timeline context, so for when this information was relevant. They might have reference problems. So, for example, implicit references to something like this system, without explaining what it means, but also undefined aliases and terminology. Especially in large organization, terminology evolves over time, and an organization can build an entire terminology for internal communications. And then you can also have like structural issues in the document itself. So a missing semantic structure. And that is on top of plain mistakes and human error. Especially with RAG, these issues are more pronounced because you aren't looking at a full document anymore, but you can be sure there's a certain contextual relevance, but you're only looking at bits and pieces. And these bits and pieces or parts of the documents, chunks, how they are called, are often created through naive chunking. So you're just chunking based on a length. So for example, like 400 tokens. And this means we have to be extra careful when we are doing retrieval augmented generation and are feeding facts into our LLM. And today on How AI is Built, we are talking to Max Buckley. Max works at Google and has done a lot of interesting experiments with LLMs, and especially on using them to improve knowledge bases or documentations for retrieval augmented generation. And we talk about identifying ambiguities, fixing errors, and also creating improvement loops for your document base. So welcome back to our series on search. Let's do it.
What Anthropic are proposing is that you have a set of documents that you want to chunk, and then for each of these documents, you break them into some arbitrary set of chunks, let's say K chunks. And then what you do is you get Claude, in their case, but an LLM, to look at the entire document and then look at the chunk with the kind of command to contextualize this chunk given the document. So one of the examples is that you might have a chunk that says something like the revenue was 43 million, and that chunk on its own doesn't really tell you anything. If someone searches for something about revenue, they will find it, but the revenue for what was 43 million? But of course, given the document, the contextualized version is something like, given the SEC filing for this company, the revenue is 43 million, which obviously has a much more meaning in it. And they use this contextualized version both for embedding and semantic search, but also for keywords and lexical search. If you had something like SEC filing or the company, then you could potentially find this chunk and not just the revenue. Obviously, there's different ways of thinking about chunking and contextualized chunking. One thing we were thinking about was like, if documents contain intrinsic structure, you can obviously maybe make use of that, right? If you have a hierarchy of headings, obviously you get some information from the file name, file path, but then you have some hierarchy of headings. So you have a H1, H2, H3. Potentially that also contains some information. Like you can flatten or ignore maybe the sort of intermediate paragraphs, but knowing the hierarchy of headings also gives you some more information that a sentence or paragraph may lack, right? And so including that can help. But the Anthropic approach particularly resonated with me when I saw it because, as I said, it uses the large context model. So to be able to process a whole document plus a chunk, you need tens of thousands tokens, hundreds of thousands depending on the document. But it also uses context caching, right? So effectively you pay to cache the document, and then each incremental thing is just a small paragraph. So they have some number cited, like $1, 2 cents or something per million tokens processed, which is obviously very nice. And most of the major providers now offer this context caching feature.
And are they doing it in fill in the middle? Basically, how we see in masked training, that you have the stuff previous and the stuff after it, and then you fill in the middle chunks as well? Or is it only the previous document?
No, it's the entire document up top. So the section that you're
Yeah.
contextualizing is effectively duplicated. So like exactly, it's the whole document.
Yeah.
But you're right. You could obviously do it the other way. You could think only include the prefix that you've seen before. A lot of these things, they're more art than science. You can try things and see what works. Another interesting area here, as well as potentially like contextualizing the chunk, is to actually have like multiple embeddings for the same chunk. So if you have a chunk, to have the raw chunk embedded, potentially like a summary of the chunk embedded, and hypothetical questions that the chunk might answer if your system is questions and answer based. And what you probably will see is a very long chunk. The distance from your user query could be large, whereas the summary might be a little bit smaller, and then the question might be significantly smaller because they're both in that same space, right? The kind of question space.
Yeah. And I think it's different problem they're fixing. The
Mm-hmm.
one where you embed the questions is rather that the question and the document live in different spaces
Mm-hmm.
and are formulated in a different way, use different lingo, use different terms. And the other one is more about losing relationships and losing information that's
Mm-hmm.
important in the context of the document.
Yeah, exactly that, right? That the query content mismatch problem is the reason for the hypothetical questions or multiple embeddings, but exactly the contextualized thing also makes it more sort of semantically meaningful, more complete. Um, and I think this is a problem that comes with chunking, right? That as you said earlier, in traditional search engines, you're thinking about documents, and a document contains a lot of information, but a chunk can be quite small, right? It could be a few hundred characters, or like 100 characters, or it could be like a sentence or some words. And obviously, on its own, it doesn't necessarily mean all that much. In the context of a particular document, it maybe means something. And so it's just a way of getting around that problem.
Yeah, and especially relative sizes. Because chunking tends to be used like when I have really long documents, and traditional search engines, like the majority of applications, is around e-commerce, where your text sizes are very small. What would you
Mm.
say are the main issues we face, especially around the internal documentation, but also around the approaches to chunking and search at the moment?
So I can only speak from my own experience, right? But I think that there's a huge opportunity that sort of LLMs provide for internal knowledge management. And specifically, I think RAG is the kind of key right now to unlocking that. If you're in a company where you have an extensive set of documentation, and not even strictly speaking documentation, it could be questions and answers, it could be historical transcripts or whatever, that can be chunked and synthesized and used to answer future questions and really expedite people's knowledge discovery process. But what we have seen in Google, for example, is like all sorts of like quality problems, data quality, document quality, effectively problems, where, for example, there may be two documented ways that something works, or one, maybe they're both correct at different points in history, right? Someone documented it on this file at one point, then a few years later they documented it on this file, and now we have two files that say the opposite as to what you should do. And only one of them can be correct, like where it says, for example, do the database update in parallel, and here it says do the database update first. Okay, one is correct, one is not correct. And again, this is something where I think LLMs can really help to solve the problem. Obviously, in the past, you could ask some engineer to go and update documentation without specifying exactly what to update or where to start. And there's a lot of documentation. There's, hundreds of thousands of files. So it's not a very satisfying task. Whereas an LLM can, especially with large context, can read in a huge set of files, and you can ask it for errors, ambiguities, contradictions, and it can give you back a list. And many of them you can go and very quickly knock out, or you can just go and change one line of documentation and that issue is resolved. You can also identify things like areas that are under documented or areas that are mentioned but not explained. And of course, these could also be action items for people to document. And then, of course, this improvement then will be reflected in the next set of like answers where you read in the newest data. But obviously, this is not perfect process, right? Given today's LLMs, you will get some hallucinations, right? If you ask for, give me 10 errors, contradictions, ambiguities, some of them are really useful, really punchy stuff. Other ones are maybe borderline stuff like capitalization, typos, small potatoes. Other stuff maybe just hallucinated or wrong. It says this is this. And especially if you ask it for file references, it can give it to them to you. You can go and check. So you don't necessarily waste all that much time looking at them, but sometimes they're just not particularly saying something. So I think having high quality data is key, and different data sources maybe have a different sort of quality bar or like a different expectation in terms of like maintenance. So for example, formal documentation might be something that people strive to keep up to date. Whereas if you have an internal questions and answer repo, maybe the expectation is that you answered a question and that was good when you answered it, and it's not necessarily good several years later, right? So how you deal in your system with timeliness of data is a question, right? You could be very clever and try and figure out the system didn't change much, so maybe the older answers are still good, or maybe you just have some hard cutoff and say, let's just throw away things from a few years ago as being out of date.
But
But
in the
yeah,
end, that's really about identifying the places where there is information and not really fixing it. And I think that's an important distinction, because for finding these ambiguities, using something else than LLMs will be really challenging,
mm-hmm.
because you would need to come up with an entire NLP pipeline to figure out, okay, this is conflicting information. You could probably supplement it with some NLP where you use like entity recognition to identify the major entities and then basically flag them and maybe reduce the document size and insert all documents where you have a certain entity and see whether there are conflicts around that entity. What are your thoughts on that? Like, how do you figure this system working? You're thrown in to a new company which has documentation issues. How do you approach it?
What you've just described is obviously possible, but sounds to me like a lot of work, right? Like you'd have to figure out a lot of systems to orchestrate the various bits. And with LLMs, you get this magically, right? That if you can just read like the markdown files out of a GitHub repo, you can write a collab that reads in 100 files, sticks them in the prompt to a large context model like Gemini or Claude, and you ask it the question, how do I, and if you have context caching, even better, right? Because then you could ask a sequence of questions over the same hundreds of markdown files. And for each one, it gives you back some kind of answer, which lets you go and either action it yourself, or maybe you file requests for other people to action them in case you're not the expert. LLM thing is really a kind of speed boost here, I think, compared to the prior. Because also a lot of these things are sometimes linguistically subtle. And what I mean by that is I've seen instances where after loading a documentation base into the prompt and asking some questions, I could see that the answers I was getting were not what I expected as someone who's worked on the system for several years. And what was interesting was I asked the model for direct quotes as to why certain things were the case, and it gave me exact quotes, and I could find the offending string. And effectively, there was this funny kind of phenomenon where a system was built on top of other underlying systems, and one of the underlying systems had a particular limitation. And the higher level system provides an abstraction that lets you get around that limitation. And generally, when people are talking about the top level system X, if they're talking about system Y, then the context of X. But in this one paragraph, they were talking about just Y on its own, and they made this statement that they said that this system doesn't support this programming language. And then the model just understood that to be a fact or something. And like every question about, does this system work? Does X work with programming language? And they would say no, because of this one offending sentence. And literally changing the sentence to be just more specific, to say, while the underlying system does not support this programming language, system X provides an abstraction on top of it that allows them to be compatible. And this like simple fix instantly meant that all those kind of questions went to the way you expect, right? That the ambiguity was gone. But the funny thing is, as a human, if you didn't know and you just read that paragraph, you would rightly make the same assumption that the LLM had just made. If you were a beginner in the company, you would absolutely read it and go, okay, so I'll remember not to use these together. So making it better for the LLM also made it better for the human.
And it's how would you actually go about figuring out that you have these ambiguities in the first place? Because in most companies, the documentation is way too large and you have way too many documents that you could just throw all of it into a long context model, or you would have to basically go into an iterative mode and iteratively pass 100,000 tokens into the LLM and just tell it, okay, are there disambiguities? How would you actually approach it in a more targeted way, maybe linking it back to the search queries or where you didn't have a hit or didn't give the user a satisfactory answer.
Mhm. So yeah, I suppose this for the first part there about how do you go from if you have like too big to fit in a large context, and even if you have, let's say, so certainly that's the problem if you have too big. But I don't think you can necessarily tackle a whole company in one go. But potentially you can do like smaller, like departmental or functional or system based improvements. But if you want to go bigger than that, if you want to dynamically gather these documentation, then that's when you're talking about the kind of retrieval augmented generation, right? When you have some sort of semantic search or it doesn't have to be semantic, but let's just say semantic search over the chunks and you return the chunks and you generate the answers. If you have one of those systems, of course, you can gather like user feedback, right? You can allow for thumbs up, thumbs down, and potentially even like a qualitative, like they can write a free text as to what was wrong or right. And even just from using the system, maybe you can see that your chunking strategy is limited, right? As a developer, you can find that there are chunks that are maybe useless or meaningless, but for some reason are still being ranked highly and still being retrieved. As in the chunk itself might have like nice headers, but then just say to do and the name of the person who's supposed to actually write the documentation. And of course, this is not something you ever really need to retrieve for any particular reason, but your model retrieves it and then suddenly it has fewer chunks, fewer realized chunks than it would have otherwise. Or the one that we commonly see is with re-ranking models that are point-wise, that score each particular data point given the query individually. They often find a good chunk, but then they find like pseudo close to duplicates of it, given like we have a lot of redundancy in documentation, especially if you look across different teams. So the re-ranking model will often give us like 4 of the same chunk from different teams that have all recommended the same best practice. And you're like, okay, we'd like some diversity of choices there. And there are list-wise re-ranking models that can get around that problem. Sorry, I feel like I went on a tangent and didn't fully answer your question.
I really like list-wise re-ranking is really interesting, but
Mhm.
maybe to go back on it, I think you can use that even during generation. I think like we are at the moment building an agent for coding, and in that we feed in documentation, but every time you make a generation, we cross-check, hey, is this actually consistent with the documentation? Because of the priors of the LLMs, it often makes a wrong choice in how to use basically a certain programming language. So these ambiguities are useful in like multiple different ways. And I think like when you can ask specific questions, it's always better. So you always have to think about basically, I'm not looking for ambiguities in general, but rather I'm looking for specific ambiguities which
Mhm.
should be informed from pre-existing user queries, which maybe failed or maybe
Mhm.
it didn't return good results, or where the generation completely failed, or where the NLI model told you, hey, this answer is not factual consistent with the input you gave the model.
Mhm. Mhm. So we are. I haven't really looked into these recitation checks for like RAG systems where you can like annotate your data yet. I only started looking into them recently. But so that if we're giving a large number of chunks, that we can say what part of the response came from or was like heavily influenced by a particular source, which is obviously nice because now we can both visually we can show it and say, okay, this section came from number 1 or this came from number 3. But of course, it also lets us see if there was some chunks that we didn't use at all. And that also lets us programmatically get data as to which ones were actually used by the model itself, right? Without relying on the user thumbs up, thumbs downing it. Because if we're retrieving a chunk and never using it, then not such a useful chunk for this set of queries.
Yeah. And I think like the most challenging part is errors. So I would love to know like how did you find this concrete error where the fact that was in the documentation was actually just plain wrong? Because ambiguity is you have the same information stated in different ways. So this should
Mhm.
be like easier to identify. But clean errors in the facts are really difficult in the end to find.
Yes, in that particular case, I had the benefit of being sort of a like domain expert in that system, right? So when I was playing with this large context model, I was specifically asking questions that I thought like a user, a beginner would ask. And I was like looking at the answers, knowing what I wanted or expected. And when I got something that kind of disagreed with that, I was able to fix it. But what I also found interesting was just asking for errors worked. I'm not going to say perfectly, it doesn't find all the errors necessarily, but it also worked, right? I asked for errors and it sometimes gave me these funny concrete examples. Or other ones were like, I didn't personally spot them, nor did the LLM. But one team who I was working with came back to me after a few weeks and they said that they were very happy with the LLM responses. But one problem was that the model kept recommending people come to their office hours. and they don't have office hours. And I was thinking, pretty sure the documentation says they have office hours. And it did 4 times. So in 4 different parts of the documentation, it said, if this doesn't solve your problem, come to our office hours. So they were saying it's a hallucination. I was like, quickly removed it. It hasn't happened since.
Go ahead.
Yeah, no, I guess the line of what is an error is difficult to quantify, right? I mean, and even if it's independently verifiable, if the system, like if the documentation says 2 things that contradict each other, that there are 2 options, and somewhere else it says there are 3 options, then only one can be correct for something. But other cases, it's hard to, the model couldn't have known that office hours, there are no office hours, because it wasn't even written somewhere that this team do not have office hours. So if we had that situation, it would obviously have been an explicitly obvious or something more obvious and fixable, but it required a kind of a user to point it out. And
Yeah. I think it only shows you like search systems, you can never look at them in isolation. You in the end need a complete team to actually fix it, like subject matter experts, but also you user feedback to actually point out the wrong information. What I'm really curious about is to get your thoughts on like misgenerations. So if the model always adds information or includes something, if that's a bias from its training data. And I think like one concrete example is always like when you ask models to write something for like anything social media, it always falls into a certain style. And I think this is also an interesting direction that your documents you also feed into the context could bias the model into a certain direction. I would love to hear your thoughts of like how would you actually change the documents you have to actually change the behavior of the generation as well.
I know what you mean in the sense that if we're putting Markdown into the as a documentation, the model will like just start spouting Markdown in its response, which is actually quite useful. But we don't have to say you responded Markdown or whatever; it will just do it. But generally, like my experiences so far with using Gemini for a generation has been pretty good in terms of it not answering when or if something is explicitly outside of the context. So if we're asking it some question like how many legs does a horse have, and the retrieval from the internal documentation in question doesn't have any mention of the anatomy of a horse, it will usually say something like, "Oh, this question is not answerable given this context." So I haven't seen it necessarily do some sort of like in-domain hallucination too much, but I haven't got an exact number on that. In terms of the actual sort of style that it picks up, difficult to say. Like I've definitely seen it like hallucinate when, especially in like longer responses, but again, not hugely badly, I would say. I think RAG in general is good for reducing hallucinations versus just like prompting the model and asking the question. So that definitely helps. As I said earlier, like when asking for like contradictions or ambiguities, probably if you ask for 10, 2 are misunderstood, misinterpreted, whatever else. Yeah, there are some there, but not a huge amount, I would say. It's like what I was doing with some of this was generating a document with the kind of model's response with here's 10 ambiguities in your documentation and sending it to some other team and saying, hey, take a look at these 10 things. And people would come back to me with fixed, not a real problem, or maybe this one isn't really ours because it's owned by that other team, so we're not doing it. And then fix, and then maybe hallucination. And okay, I'll take it. But in terms of like the models prior, hard to. I haven't done any more detailed analysis to say that it's there or not. One thing is the case, right? Is that like in a company that's been there for a long time, a larger company, you're going to have a lot of internal like evolution of language. So a company that has hundreds of thousands of employees, been there for 25 plus years, is going to have its own internal vocabulary, its own way of naming things. And what's interesting is if you use a model like a model, but let's say for example Gemini, like a priori it doesn't understand the internal language of a company like Google, or it doesn't understand how we use certain words. But given the like RAG or large context, it picks them up kind of on the fly, which is quite impressive. The in context learning there is nice. Effectively, we're asking a question that has a bunch of terms that are like, I wouldn't say meaningless, but they don't have the same meaning in the inside outside world. And in some cases, we're using an internal, or sorry, a externally available embedding model, right? So that embedding model doesn't correctly embed the relationships between some of the words because it's unknown kind of vocabulary. I mean, they're words, but they're just not the general use of the word, right?
Yeah. Do you think it would be easier to run this only on the retrieved context? So basically, on every query the user gets, launch a background process which just asks, hey, are there ambiguities considering this query in this context, and feeding like the 10, 20, 30 chunks we just retrieved, and just run this continuously because you have the contextualization of the user query as well.
You certainly could, and write it out somewhere like in the background. That sounds like a great idea. Maybe I'll do that. Thank you. Absolutely. What's interesting for us, at least, is that I was giving the example of like terminology. Terminology is difficult as you go broader, like across the whole company, because some of these systems the names could be used in different ways, in different contexts, in different teams. Being consistent is easier within a particular team's code base than across the whole company. So just like loading our use of the word and trying to align that is a lot easier than trying to align across teams or across the whole world, the globe, as it were. But yes, you're right. Especially when we retrieve like across the entire company, we're going to get lots of different chunks, and maybe they'll say different things or whatever else. It would be useful for us to keep track of these errors that happen in the background and then actually fix them. I hadn't thought of that, so yeah.
Have fun implementing, like great weekend. How do you actually think about definitions? Because I imagine you have quite a lot of terms or lingo you use internally for different systems. So how do you actually think about the use of definitions in, and when to actually add the definitions also into the context? Or do you always just run the rag and the definitions are parts of the chunks as well?
So this is actually one that we have I have more detailed thoughts on. So actually, that was something that was some other people in my team found in earlier LLM efforts, right? That the LLMs were just not aware of Google internal semantics and vocabulary, and so they actually found that adding a kind of a quick glossary of terms to the kind of beginning of the prompt, or like I suppose in the system prompt, really helped in terms of the tasks they were trying to solve. When we moved to large context approaches, then a lot of these could be picked up almost implicitly by the model, right? Given like the model had dozens of hundreds of files, it sees all these terms being used in many different contexts and seems to be able to intuit what they actually mean, right? Or some of them will be defined at some point and other ones would be maybe just implicit. Though one funny failure mode again that we saw with the large context approach was as you said, many systems have a lot of aliases, right? Like different people refer to it as different things. They maybe use the code name that was being used when it was being developed. Maybe they use the external cloud name for the thing, as opposed to the internal name. There's a lot of different aliases for the same thing. And when we were like looking at some of the questions answer system data, we noticed that there was a particular subset of queries that were using a particular name for a system and not retrieving the kind of relevant content. And effectively, they were using the name for the back end of the system instead of what most people refer to it as. And so the fix in this case was literally adding one sentence to the documentation that said, X is a backend for Y. And every query that we've had since that asks about X found the right thing. But until that point, just that, if we had the entire documentation of the whole company, or potentially we would have got around that problem, or like semantic search or lexical search potentially there. But this was when we were just using large context and the documentation for a particular system. So that one sentence fixed those subset of user questions, which was pretty cool.
Yeah.
But yeah, as I was gonna say that in general, right now, a lot of what we're looking at is semantic search. So we're embedding the query, and it does seem to find the matching terms. If we don't, like, even though we're embedding it with maybe in my current project, we're using an externally available embedding model, but it doesn't necessarily understand the full semantics of that internal term, but it still finds the things that are similar. It finds the correct things.
Yeah, and on a previous podcast with Niels Reimers, we talked about like knowledge editing in embeddings is actually way easier than in language models. So the source of failure is probably rather the language model, because it will, from its prior knowledge, mistake the definition or the term for something else, as opposed to the embedding model. Because in the embedding model, if you fine tune it, you can basically ingrain it as a different entity based on the similarity you give it with through the continued training.
And so we've had good success here, right? Some systems, for example, are just a normal external word. So if you ask about like guitar, for example, it's a system at Google, but also a real musical instrument, depending on the approaches we've tried. But if you do like RAG, of course, you return a bunch of documentation about how do you set up the system, and very little to nothing about how do you play the musical instrument? So the LLM does a good job of answering the question about the system and not the musical instrument. Probably if you asked it about the musical instrument, you'd have a different challenge. It would probably understand that you're just talking about it, and it would continue, like it would say, state something like I said earlier, where it says that there's no information here about playing the musical instrument.
Yeah, I would actually love to know like your thoughts on like more context misinterpretation. So when I have, for example, the sentence like product A was replaced by product B in 2020 and product B costs $100. And then I have a user query with this context, like how much does product A cost? Which information just isn't available, but even if it's available, it could be like screwed up by the LLM. So have you spent any thoughts or efforts of actually like minimizing context which could be misinterpreted by a reader or by an LLM?
So yes, so as I say, I did do like myself, like trying to for a particular system, more using it as a kind of proof of concept, like where I found these kind of chunks that were ambiguous or unclear, or where the thing was citing something. I was like, I found that it was quite fruitful to like literally fix those simple sentences if they could be done. Now, of course, that doesn't scale to a whole company. But one thing I would like to do here, and I haven't done this yet, is to potentially use these things at pre-submit time. So to actually imagine that someone is changing, and this obviously could be in Google or it can be externally done as well. If someone is changing a markdown file, someone is like modifying or updating the documentation in a company, it would be great to have an LLM check that change. At the simplest thing, it could be checking it just for like English readability or like language of your choice and readability, but also like how clear is this, right? Because sometimes people write something like start a sentence with it and they don't say what it is. Maybe it's a new paragraph. Of course, better to say what it is, especially if it gets chunked, and don't rely on the header above it or whatever else. But also just actually, does this sort of section make sense in the context of this file or even in the context of this whole directory? And this way you could prevent some of these issues going in the first place. So you could improve the quality of things that are getting submitted, which of course in turn would improve the quality of things that are retrieved. And I also think that if someone is modifying the documentation, they have it loaded into their personal context, right? They're perfectly positioned to read that like automatically generated comment on their change. It says prefer this, or try maybe rewording this way, or break this sentence into two sentences. Like it's simple stuff, but it makes the thing more readable to a human and also to an LLM.
Yeah. And it might even be interesting. That's just more of a crazy thought because it's another document. The similarity should work very well with the already existing documentation. You could just do a naive chunking on the entire existing documentation and run a retrieval on it and feed all of the like above a threshold into a long context LLM again and see whether there's any contradictions in there with the piece of documentation you're currently writing on, and then you just highlight it to the writer.
Yeah, you certainly could. And you certainly could. As I say, that's a good point. Like you could, like given what they've written, look for that, find the similar things and tell them that it's similar to this or that. In theory, they can reuse those things. They can embed or include those other documentation in their documentation rather than having to duplicate it. They can potentially use it to sanity check what they're writing, especially if they're not the team that owns the system, right? If they're just a sort of third party team that's writing a kind of summary of what the system is for their team, do they want to be correct? But I really like your idea here of even just, for example, if we have the RAG system set up, setting like K to a large number, like 100, asking a question. And then with that 100 things in the context, you could ask for contradictions, errors, ambiguities, and you would effectively get it across the entire code base for a particular query.
Yeah. I think like we talked about a lot. I just want to have a list of stuff to look out for, which is like errors, ambiguities, contradictions, out of date information, inconsistent information, lost relationships, missing definitions. What else is out there, in your opinion, that people should look out for in the documentation when they're doing RAG or in general when they're doing RAG?
Say the contextual retrieval, contextualizing the chunks, right? The most naive approach to chunking is to do, say, 100 character sequences or something. That this obviously is bad for many reasons, right? Because you're splitting potentially words. There's obviously more natural things where you split on new lines, on paragraphs. But of course, not all documents are well behaved. Some people, you'll find that when you do your clever chunking strategy beyond the 100 characters, that some people have put everything in one sentence or everything in one giant wall of text. So you do need some kind of fallback heuristics. But even when you do these things, you need to say, are these chunks meaningful, or like what extra information can we capture with the chunks? And if you're using like any kind of structured data format, then you can potentially have the chunk, maybe the headers that are above it, the file reference. Maybe you can have additional data generated by LLMs, right? You could have a summary of the document, or you could have, like I say, the contextualized embeddings or hypothetical questions, all of these things. But of course, all of these things rely again on the quality of the source data.
Yeah. And I think the two different types of contextual chunks is like basically position, but also information, which is just missing. So basically, if I have like this without a reference to it, these are like, I think, the two major types. Especially, I think in Anthropic's case, they rather tackle the second one. So basically the missing information and not the positional one. In the positional one, you can get into a lot of areas, like depending on the type of information you have. I've seen HTML RAG. I'm not sure whether you've seen that paper.
No.
Who are basically trying to do something similar for HTML, as you mentioned in Markdown, but only take semantically meaningful elements in the HTML tree, which is also really interesting. Nice. And I think the LLM space, it's like such a hyped area at the moment. I always like to ask people like underappreciated and overhyped. What do you think, like in the data and AI space, what's an underappreciated technology and what's like an overhyped technology?
I mean, I feel LLMs are clearly not underappreciated or underhyped. I fear we're at the cusp of an AI winter, like in the sense of not that the things aren't great, but just that with the scaling slowing down, some of the momentum will be lost. I think that's not a problem in the sense that I think that RAG is hugely valuable. I think that for a lot of companies, for a lot of use cases, this can solve the problem in a way better way than we had before. Like a lot of like customer service type use cases, this is amazingly useful. Like you could have a small team of elite customer service people supporting a huge army of bots. And again, just every correct answer that they give becomes like gold for future iterations. And that's what is happening with the documentation here. If you can document it correctly once, then it can be found and synthesized for hundreds of user questions going forward. And that's super valuable to me because I don't want to answer the same question twice. I think that like right now we're obviously very focused on LLMs. Obviously traditional supervised learning and all that is still there, but not getting as much hype. But I think obviously that's the very useful. I mean, my feeling is that things like AlphaFold will be more significant historically than LLMs, but that's just my intuition. I wouldn't say it's not hyped. It's obviously getting its own traction, but it's not as accessible to normal people, I think, as ChatGPT is.
I think in the future we will see more and more AI systems where you actually combine multiple types of AI to actually get a good output. And I think RAG is already an example for that. You have the retrieval system and the LLM for generation, and usually your retrieval consists of multiple components as well, which often include like more of the traditional AI in the form of classifiers.
I think that one thing that I think will happen out of this like huge hardware buildup for LLMs, it looks like LLMs are seemingly plateauing, according to some of the news I've been reading in terms of scaling. But all of this hardware build out will make it much easier and cheaper to do all sorts of data science going forward. You won't have as much of a struggle to get access to GPUs if someone went and built millions of them for LLMs. All sorts of other sort of supervised learning use cases and unsupervised learning can be potentially done. I think it'll be a lot easier to found like a deep tech or a deep RL startup today than it would have been several years ago, especially if my suspicion about the AI winter comes true.
Yeah. And also with the trend that they are doing specialized hardware for LLMs. And when LLMs are here to stay, like they will probably move on to specialized hardware. And then you have an abundance of GPUs for other types of models.
One thing I really liked watching your podcast, the other episodes, was like one thing that's interesting is search is not a new space. But I feel like with RAG, it feels new to a lot of people, or it's like a discovery to people. Like people, like there's all these sort of fields that are partially overlapping and they're converging in this kind of fun way. So it's very interesting to see, even within Google, like different people have approached RAG very differently. Some people are really just focusing on query, like actual prompt optimization, trying to get the prompt right to make the model work a certain way. And then other people thinking much more deeply about the actual data, like myself, or maybe some more people focus on the infrastructure. And it's interesting because people are just coming at it from different perspectives with different kind of priors. So I think there's going to be even more fusion of these communities over the years to come. Like I think we're democratizing some of search. Like I think that RAG type use cases make search useful in all sorts of domains, and multimodality means there could even be more domains.
The thing is, like search is having a renaissance, but we first basically had to rediscover a lot of the stuff which was already figured out. And I think that's always when like there is a new technology hype cycle, you combine it, you figure out new ways of using it, and where you're building on old technologies without really knowing or thinking about the old technology, which would save you most of the work probably.
Mm-hmm. Yeah, it's fascinating. Like for me, at least, I took some Coursera's on back in like 2014, maybe on like how search engines work, the kind of old TF-IDF BM25 things, and built some simple things. And I hadn't really thought about search. I obviously use search at all, but I hadn't really thought about it or built search systems until kind of end of 22, beginning of 23. So it was interesting to go back and see, okay, there's been a lot of progress. And again, some of these things work really nicely just now. They're so easy to use. Like it's so easy to prototype with some of these LLM applications. Like this is one thing I love with large context, that you have some documentation for your company. You can just slap that in there, ask a question. If it can answer it, you're like, all right, it works. It's business value in a couple of hours.
Yeah. And what is something you're excited about, or what is something you would love to see built in your field or around it?
I'm very excited about all things AI. I think it's a very exciting field. I have this like lucky coincidence that I got into ML in 2012, end of 2012. I just discovered the term machine learning. So I've been like chasing this for a while, and then it suddenly became the coolest thing ever in 22. So it's been very interesting to watch. While I'm new to search, I'm not new to machine learning. It's really interesting to see how this whole thing plays out. I wouldn't have thought, I don't know, that we would have had ChatGPT publicly in the end of 22, and I was taken back by how good it was, and like have since been just impressed by the progress. I'm happy to see where it goes next. Riding in those self-driving Waymos is also pretty cool. I can attest to that fact.
I think, are they in Zurich? No, right?
Oh, no, in
No.
San Francisco.
I think in Europe you will have to wait a few decades before they come here.
Yeah, I'm a little bit worried about Europe's approach to AI, to be honest. Like it feels when you're last place in a race, it's not a great idea to tie your shoelaces together.
Yeah, US innovates, we regulate. Yeah, that's the fun stuff. Nice. And if people want to follow along with you, where can they do that?
LinkedIn is probably the best place. I post stuff reasonably regularly.
Yeah, and I will put that in the show notes. And Max is a really good follow, especially when you want to stay up to date on a lot of research as well in like the retrieval space. I think I've been abusing Max's post a lot to not do the work of actually finding the interesting paper. So what can we take away? I think the key idea is to make your documentation ready for AI. And I think this is a theme we will see more and more across different types of documents and across the labor we are working with. So, for example, also in code, that a lot of work will be spent on making code bases or documentation or anything else ready for AI. So actually we can use LLMs optimally. We can send agents in there to fix bugs or to write some new features at some point in the future. And I think, first of all, we have to fix up what they are in the end working with, because we might have like inconsistent documentations, some wrong facts in there, ambiguities, all of which has to be removed so AI doesn't make mistakes, which are in the end then caused by factual errors. And for search specifically, I think it's very valuable to make like the different document quality issues you might encounter explicit, and just to be on the lookout for them and to do spot checks, or just feed like a large portion of it where you might expect failure cases, or which is like a particularly important part of your documentation, feed it into a long context window LLM like Gemini, and just ask it whether it can find any inconsistencies, any ambiguities, or whatever. I think in general the more sensible approach would be to actually do that on the fly. So actually when you're running a RAG system, you probably are re-ranking anyway. So you can do one additional model call without immense cost. It depends on your load in the end, but you can, if your load is too high, that you don't really want to spend like the model cost of feeding all the chunks into an extra LLM and asking it, hey, are there any ambiguities? Then you could do spot checks. So on 10% of the generations, just take all the chunks, throw it into a long context LLM, ask it whether there are any ambiguities, any factual errors, and when it classifies them as factually inconsistent or whatever, just throw an error, maybe re-retrieve, and with something else, for example, fall back to BM25 and actually throw the error or a warning so your search people are notified and can actually look at the specific chunks and correct them themselves or with an expert. And I think this already is a good feedback loop to be consistently improving the materials you're working with. And I think this can get you out of that you have like a lot of silent killers in your search database, because a single ambiguous sentence might corrupt an entire set of responses, and fixing those often is like not enough work, but identifying them is really challenging. And especially if you have a really large search database, finding this is completely infeasible. So you have to do it consistently and over time and continuously eradicating the mistakes. We will be continuing our series on RAG explicitly next week. I would love to know what you think of this episode. Let me know in the comments. Also, like and subscribe. I will talk to you soon. Catch you next week.